Hello everyone, Matt and Mac here from the Wi-Fi Ninjas. We both work for a company called Natilic inside the UK. How are you, Mac?
Never better. Thank you. And you?
Splendid.
Good to hear. Both of us were involved in this beautiful warehouse design project from a very beginning, where it was all a pile of dirt in the middle of nowhere. Since then, a massive warehouse was constructed with a massive racks inside, and it was as challenging as it was fun.
So in this presentation, we are going to be talking you through how we designed the Wi-Fi for this 720,000 square foot warehouse from start to finish. As you can see, it's a pretty large warehouse covering 720,000 square foot. And we have multiple mezzanine levels and we have extremely long aisles to the side of me that span over 130 meters. They also go up to 18 meters high, and coverage is required at all levels in between. So from the ground all the way up to 18 meters. And we also have external areas where lorries come in and all that kind of stuff. So we're going to take you through all of that, how we did it, why we done it, and we look forward to taking you through that next. So one of the biggest challenges we had when it came to doing the design for this warehouse was the aisles. And that's because the aisles are 130 meters in length, 18 meters in height, and there's just a 2 meter gap in between each aisle. And to add on top of this, the trucks that drive down here, they have to be able to scan the pallets at any height from ground all the way up to 18 meters. So not only did we have issues with trying to cover the whole aisle because of the length, we had to think about the height and we had to think about mounting. So as you can see behind me, what we decided to go with was the most directional antenna available to us from Cisco, and this is a 13 dBi patch antenna. Now we are standing at one end of the warehouse. At the other end of the aisle, we also have another access point and another antenna. So we are shooting down the aisle from both ends. And now we've tilted the angle of the antenna at the end that you can see us on now with a 20-degree angle of tilt, and the antenna at the other end at a 30-degree angle of tilt. And there was some specific calculations that we had to do to figure out how we were going to tilt this. We'll probably describe that in another video why a bit later on. But whilst we're up here, what you can see is we had to come up with some custom mounting for these antennas. Mounting, mounting, mounting. When it came to doing this installation, mounting was a particularly challenging part of the installation. We could not just use the out-of-the-box bracket for these antennas. We had to come up with a special, unique way of mounting these antennas to what we had available to us. Because we wanted to have all the antennas at the same height, at a certain degree of tilt, and had to figure out how we're going to mount them and where we're going to mount them in here, we had to get quite creative, and we actually used scaffold pole with some Jubilee clips mounted with a special bracket to the cable tray. And I have to say, great job to the installation team that did this, because they certainly, I don't think we'll be getting a Christmas card from this year, because they did not like us by the end of the project with the amount of tweaks and specificness we gave them on mounting. Yeah, it was a big challenge for them, but they smashed it. It looks great and it works great, and that's one of the biggest things that we had to think about when we come to this installation. And you can see here clearly on the picture how they are mounted and how they are all in the middle of the aisles, shooting down the aisles. So the solution for this warehouse was a full Cisco deployment. So Cisco DNA Center, Cisco wireless LAN controllers, Cisco access points, and Cisco antennas. We have multiple types of access points and antennas deployed throughout the warehouse, which we will take you through during this presentation. But also we just want to call out that the clients that are going to be used in this warehouse are 5 gigahertz only.
This is the typical office where we would use typical omnidirectional access points with built-in antennas.
And now here we can quite clearly see that this is not a typical office deployment where we could use purely just internal omnidirectional access points.
This is warehouse. Surprise. We can see all of our access points around the warehouse, in and out, and this is what we've used. In the central part of the warehouse, we can see quite a lot of racks, tons of racks. And that's where we've used our directional 13 dBi gain patch antennas. In the bottom section of the floor plan, inside the building, this is the only part where we use omnidirectional antennas, and we can see 4 omnidirectional antennas mounted against the wall in the pallet section, and 6 omnidirectional antennas mounted under the mezzanine ceiling. We have internal omnidirectional antennas access points with built-in antennas mounted in the office to the right. And also we have external 1562i access points with omnidirectional 180 degrees antennas mounted on the outside of the building.
How about this beautiful, antennas and tilt? How do we tilt them? What is the thought process behind tilting a highly directional antenna in a warehouse? So since we have where we stand, omnidirectionals here, they cover very nicely this area on the ground floor going towards the start of the racks, of the aisles. So the antennas behind me, you can see them slightly at 18 meters height there. They are tilted 20 degrees down, which is about that. So with this slight tilt down, they will cover most of the length of the aisle. However, on the other side, on the very far back side of the aisles, we don't have omnidirectionals there. So we will have to provide some coverage from the antennas from 18 meters high. If we maintained 20 degrees tilt down, they would provide some coverage, but the coverage would be quite low. So we have tilted them down even more at around 30 degrees. So they not only shoot in between the racks to provide some coverage from that side, but they also cover ground level quite nicely. We use Cisco 2513 antennas with 13 dBi gain. This is what the propagation pattern looks like. And we are going to be installing them in the warehouse around our main racks that are 130 meters long, 18 meters high. We also have few mezzanine floors, 1, 2, and 3, and under Mez 1, we have some omnidirectionals installed with antennas pointing down. These are in fact the only omnidirectionals that we've used in the warehouse. On the other side of the warehouse, on the left-hand side, we do not have omnidirectional or any other access points installed. So the APs on the right-hand side, they are designed to cover everything under them and around them on the ground level, because here this is just pallets or people that are never too tall. We know that we can install our directional antennas on the left-hand side against the wall and on the right-hand side against the cable tray using a custom bracket. Now the question is, how do we tilt these antennas? Do we point in the middle at 65 meters away from the antenna, or do we point somewhere else? So on the left-hand side, since we do not have omnis there, we want to cover area under the access point with the directional, which means that probably I wouldn't like to be shooting anywhere near the center of the rack. I will probably be shooting somewhere closer to the antenna, which would be, let's say, 35 meters away, because this looks good and feels good, okay? So we have 90 degrees here, and we want to calculate this angle, x1. We know this is 35 meters here, 18 meters here, so we can calculate that angle. With 30 degrees beam width, this antenna will be covering something like that, okay? But still, remember that even outside of the main beam width of 30 degrees, it will still be covering quite a lot. And the requirement was to not only cover everything on the ground level, but also at 80 meters high. So we cannot tilt it too much. It must be a good balance. On the right-hand side, however, we have these omnis, so we don't have to be shooting that close. Let's say that we will aim to shoot 55 meters away from the antenna, which will be somewhere around here, okay? And this will create that triangle, 90 degrees here, and I want to calculate the X2 angle of tilt of the antenna on the right-hand side. So this antenna main beam width would be covering something like this, and also I would expect that antenna to cover pretty much everything around. So we have coverage at all heights of the rack. Now to calculate what is the angle X1 and X2, we will use basic geometry calculations. So we will use for X1, take my word for it, if you have any questions, reach out. Tan to neg1 from 18 divided by our distance, 35, which happens to be 0.6, and I've used the calculator before. This gives us an angle of 30 degrees, and angle X2 on the right-hand side. We also use tan neg1, 18 divided by 55 meters. This was 0.36, and this equals 20 degrees. And this is how we have calculated these values and used them in our design. But most importantly, we have validated it using AP-on-a-Stick validation survey.
And what we can see here is the post-validation survey results, and we are purely focusing on two of our directional antennas. The image on the left-hand side is of the directional antenna against the back wall of the warehouse, where it has a 30-degree angle of tilt. And then on the right-hand side, we compare that to an access point antenna that is on the other side of the warehouse that has a 20-degree angle of tilt. Now we can clearly see the difference in the coverage heat map of how far it goes at a different angle of tilt. And what you can see here is a semi-directional antenna that we used from Cisco, which is a 2566D4M. And now we can see what the antenna looks like on the left, how we had it set up for our AP-on-a-Stick testing in the middle, and then the propagation pattern on the right.
Do you want to blast your entire warehouse with coverage from the omnidirectional antenna? Didn't think so. Neither do I. Okay, so you can see there is no walls around us, so there is nothing blocking signal from propagation from this beautiful access point. So if we had used omnidirectionals here on the mezzanine floor 3, we would have covered an entire warehouse with every single access point. What we have used instead is a patch antenna from Cisco, which is 65 degrees, 6 dBi gain antenna. And instead of mounting it against the wall and covering everything in front of it slightly tilted down, we have decided to create a cone of coverage shooting from the top, therefore maintaining a small cell size. So we just cover what we want.
And this requires no further introduction. It's an omnidirectional, boring. The highlighted access point on the bottom left is one of our 10 omnidirectional APs with omnidirectional antennas, external antennas used inside the warehouse. And you can see that it propagates a lot. It screams Wi-Fi everywhere. And this is with racks full of stock, okay? There are full of boxes everywhere. And this still goes like at 30, throughout the 30% of a warehouse, perhaps. So try to imagine if we had used only omnidirectional antennas everywhere inside the warehouse. That would look totally awful.
And for this section of the warehouse, it's a lot of open area space, so we decided to use omnidirectional antennas so that it would cover this area very nicely. As we can see behind me, it's going to be a lot of pallets coming in, coming out, no aisles specifically, so we just thought we would spread and cover nicely this part of the warehouse, but also take into consideration that this meets the start of a lot of the aisles. So from these omnidirectional antennas, they would also provide some coverage as you start to go down the aisles.
This is obviously a warehouse, but they also have an office. And that is where we use 9120s, access points from Cisco, that are internal omnidirectional APs mounted against the false ceiling as you normally would in the enterprise vertical.
And what we can see here is the coverage from one of our outdoor external 1562 access points from Cisco. And this access point is purely to provide outdoor coverage for where the lorries come in and they park up and they offload and then reload all of the stock. Where's the video? Where's the AP gone?
There it is. Okay.
Okay, so finally, the last area that we needed to cover for this warehouse was outdoors. And as we're in the UK, we are enjoying the fine, great British weather whilst we're doing our post-validation survey, getting nice and wet, holding the umbrella whilst Mac's doing his survey.
Yeah, I have a nice IoT umbrella robot with me. It's like voice controlled. Matt, can you hold an umbrella for me?
But as you can see, just behind us, underneath there, we've got a 1562 Cisco access point, which is a external AP that we have used to cover where the lorries will be coming in to unload and reload all of their pallets and stuffs, and they can do the scanning of what the stuff that's coming in, and the drivers can connect their phones to the Wi-Fi whilst they're sat in the cabs.
And watch Netflix while the lorries are being loaded with stuff. Okay, so these antennas, these access points, they're actually quite easy to work with because they have built-in omnidirectional, well, they say it's omnidirectional antennas, but it's around 180 degrees covering in front of the access point. But there is no external antenna element, which makes it very easy to install. And they are also waterproof, weatherproof, and just good looking, and they work perfectly well. So where do we have the antenna? We have a massive warehouse here. This is like the outside area of the warehouse, and then we have a big car park there. Thank you very much, umbrella robot.
No worries.
Okay, and then we have some lampposts behind us. I'm not sure if you guys can see that, but we also have some APs on the lamppost. So across this entire length of a car park on this side of the building, it must be like 700 meters. I'm not sure what it would be in feet or foot or whatever you call that. How many access points did you use, Matt?
Don't know, I can't remember, about 16 maybe.
Okay, he's well prepared for recording the video about the Wi-Fi designed for outdoor spaces in a warehouse.
Well, by this point we'd have shown everyone where the APs are, so it's fine.
Okay, cool.
I don't think people will be distracted by the puppy.
I'm recording, by the way.
Oh, it's fine, Matt can just cut that part out. Hey everyone, in this video we're going to be talking about our warehouse Wi-Fi design, but we're also going to be referring to the different types of wireless surveys that we've done whilst we were on site. So in these next videos I'm just going to explain that terminology and what those wireless surveys are. Good boy.
Yes.
What type of survey did we do? Did I hear you ask? Well, we were engaged in this project whilst this warehouse was just a pile of dirt in the ground. There was nothing here at all, nothing for us to come and test. So we got given the floor plans and a set of requirements. So what could we do? We had to use Ekahau, of course, and we had to predictively model where we wanted to place access points and antennas so we could come up with some sort of bill of materials to provide to the sales team, to the customer, so they can understand how many access points they need, how many antennas they need, and what's going to be required on site. And then once the warehouse had been constructed and there was some stuff here for us to come and test, we did an AP on a 6 site survey. So we come on site with the access points, multiple different types of antennas. We had to come up to the third floor mezzanine, mount our tripod, test different angles, test different positions, go to different parts of the warehouse and do more testing with different types of antennas to figure out what we want to use and where we want to use it. And of course, we had to do a post-validation survey, which is what we're doing today. And I'm using my iPad, my Sidekick, and Ekahau. And considering this is a 720,000 square foot warehouse, the fact that I can just carry this nice, small, lightweight tablet whilst I'm doing my survey is an absolute dream. It saves me my back, my arm, my legs, everything. I love it. Wireless predictive survey. What is that? Well, this is simply when we are predicting what we think the wireless signal is going to look like. So how do we do that? We take a floor plan and then we load it into our echo file. We draw some walls, some attenuation areas, and then we place some simulated access points and antennas in positions where we think that they need to go. And then what echo is going to do is predict what the wireless signal is going to look like. So this is what we mean when we are referring to a wireless predictive survey. Purely simulated, all in the software, no physical testing, just purely simulated wireless predictive signal inside of Echo. APOS Survey. What is that? Well, that stands for Access Point on a Stick Survey. And while we don't quite stick an access point on a stick, we use a tripod. So it's kind of like a stick, but that's what we mean. And what we're doing here is we're taking a test access point onto site with some antennas potentially, and we are placing the access point and the antenna on a tripod with a battery pack. And then we're putting it in the positions where we have placed on our simulated predictive design, and we are verifying that these positions that we are putting them in are matching up to what we predicted. Is the coverage what we expected? Is the antenna reaching as far as we thought it would? Are these walls attenuating the Wi-Fi signals just like we thought they would? Or are they different? And then we take this information and then we go back to our wireless predictive survey, and then we update the walls, the attenuation areas, our positions where we place the access points and antennas. And that's why we use AP on a stick site surveys. And when we're in very challenging environments, they are even more important because we can't always predict what we think the RF is going to look like. So when you see us talking about an AP on a stick site survey for this warehouse design, that is what we're referring to. What we can see here on this slide is a very crucial part of the wireless survey procedure. We got the client devices and we tested that they worked as we expected them to work whilst doing our AP on a stick site testing. And we can see clearly in these pictures us walking around with the handheld scanners that are going to be used inside of the warehouse. And what we've done, we connected that to our test access point and antenna and measured the signal strength that these devices would see the signal from in multiple locations. And finally, wireless validation survey. Well, what is this? Now, this is the final stage of the wireless project where you go on site and we are validating that our wireless predictive survey, that it matches what we're expecting it to be. We've done our AP on a stick testing to validate that our predictive model is what we think it needs to be, or we've gone back and we've changed what our wireless predictive survey looks like. And now the installation team have been busy. They've gone in, they've installed the access points, they've installed the antennas. If it's a large deployment, we could be talking hundreds of access points, and we've done a configuration. You've done the configuration on the controller or the cloud, however, whatever system you use. And we now go in and we use Ekahau. I like to use it with Connect, iPad and Sidekick. And we're going to go walk around and we're going to measure what the RF looks like now everything's been installed. And this is a great chance for you to validate that your wireless design and your wireless implementation looks how you're expecting it to look like. Sometimes wireless controller systems can think they're very clever with their auto channel configuration, their auto power levels that they like to use, and sometimes the dynamic channel widths. We need to go in here and validate that not only is the RF coverage, the RSSI looking what we want it to look like, but also has the configuration of the channels been implemented how we like it to be. What's the power levels like? Are there the data rates enabled that we want to have enabled? This is a very, very crucial part of the wireless project, and it's usually, unfortunately, one of the ones that gets skipped sometimes due to budget constraints. But we really recommend that you push hard to do this part of this wireless project, the validation survey, because it's a great chance for you to validate everything should be how it's expected it to be. And if it's not, you can make some changes to make it how it should be. So when we refer to a validation survey in these videos, that's what we're talking about.
This is a patch antenna. And this is how this patch antenna propagates. On the top, we can see our predictive design and how Ekahau thinks the signal will be propagated using free space path loss. In the middle section, we can see AP on a stick validation using the same patch antenna as we've used in Ekahau. And you can see that it's extremely similar to the simulation that we have done before. And on the bottom part of the picture, you can see the validation survey. So this is the live environment that we have surveyed after all the access points registered to the controller.
And now we can see the beautiful heat map from our final post validation survey. And look at that. Coverage is exactly how we predicted it would be. We have coverage down the aisles beautifully, just like we wanted. We've covered the external areas, the office areas, underneath the mezzanines, and it all works amazing. The reason why you can see some white on the floor plan is because they're actually constructing another part of the warehouse during our final post-validation survey, but we were extremely happy with our results, which we can see here. So that's it, guys. That's our warehouse Wi-Fi design video presentation. We hope you liked it and enjoyed how we went from start to finish for the complete warehouse Wi-Fi design.
It was a blast of my life. It was so amazing, and I'm so jealous because normally this is Matt's project and he always has the best projects out there. I wanted to use this opportunity as well to thank Open Reality and Ekahau for organizing this beautiful Wi-Fi Design Day 2020 for us. Thank you very much, guys, and we really hope to see you again next year.
Yeah, next year, hopefully it won't be virtual and we'll be able to see you in person again. We look forward to seeing you all. And thank you very much, Open Reality and Ekahau.
And you also want to wear a super comfy shoes.